All right, Land Desktop and Geospatial Tools. Well, to begin with, I'm using Land Desktop Companion 2009. So it's built on top of Map 3D 2009. So as far as geospatial tools go, I only have tools in as much as what was included in Map. So currently the Civil 3D portion of this demonstration we'll do in Civil 3D 2012, which means that the map tools that exist in 2009 are already more than 3 releases old. So, but just to give you a little background where we're starting from. So what I want to do here, let's go ahead and let's create a new project. So we'll go ahead and start a new job here. We'll create a project. We'll call it Project G for Geospatial. And then we'll talk for a few minutes about what it is we're going to try and accomplish. So we'll put that in the drawing folder and we'll call this just data for right now. Grab my drawing template. We'll set it to Imperial 50 scale. And new project means new point database, and we'll say OK. So once again, I'm in Land Desktop. First thing that I would point you to as it relates to geospatial tools and the functionality that's available is the task pane. That is probably for many Land Desktop users the first thing that you try and figure out how to shut off. It is very helpful. The ability to access geospatial files, whether they be shape or otherwise, within your civil environment can be a very beneficial thing. If it is off, we can turn it back on with the Map W space and turn on the task pane. We'll see that displayed here. The other place that we'll access geospatial tools will be through the map pull down right here, and we'll have access to those underneath that pull down. So with that being said, I've got a number of tools, but once again those tools are only available to me as it relates to map. There are no special geospatial tools that are available for civil or a civil type of a context. Now in this particular situation I need to construct a surface. I also need to start generating some pipe runs, and the originating data that I have given to me is 2 shape files. So from a Land Desktop perspective, there's not a lot that I can do. I might be able to view those files as geospatial entities through FDO or through the task pane. I may also be able to import them as shape files and then try and build a surface from contours, but I can certainly facilitate or work with that data much faster using Civil 3D. So let's flip over to the Civil 3D side. And in Civil 3D, the first thing that I'm going to do is we'll bring in or construct our surface from the shapefile data. Now in many cases we'll receive shapefiles from customers, and it could be made from a number of different applications, but that shapefile will contain not only the geometry that makes up the contour but also the elevation, which is the important thing. So if we're going to construct the data from that, the contour lines within the shapefile or the geospatial file format will require an attribute equal to what the elevation is. So we'll go ahead using Civil 3D and we'll construct a surface from GIS data. And the type of object we'll create is a surface, the only option that we have at this point. We'll give it the name EG for existing ground. I'll establish a style just so that I can see it a little easier on the screen. We'll say 1 in 5 background. And we'll say next. Our next option is to connect to data. You see we've got several options to pick from: an ArcSDE file, Oracle Spatial Database, or a standard shapefile. In my case, we'll go ahead and select the shapefile directly, and that is going to exist out here on my desktop under Geospatial Files. I've got a shapefile for my existing ground surface. So we'll go ahead and select that. We'll click on Login. It shows my feature class information is my existing ground. It wasn't set up to be any particular projection. If it were, I could use that to transform it into the file that I'm currently in. We'll step over to Next. If I wanted to limit the extraction of those contours to a particular area, for example, I was given a shapefile containing contour data for an entire county that was 600 and some meg to deal with. Rather than processing all of that data to build my surface, I could instead create a polygon or a fence or a circle and then tell the system to just worry about building a surface in that particular area. In this case, we'll do the entire surface. And then mapping wise, we'll see that these are the geospatial attributes that are included in that shapefile. I just need to match that to the Civil 3D property elevation. So the attribute that's controlling the height of the contour is elevation. I'm going to map that to the elevation of the contour in my Civil 3D surface. I could save this data should I like to do this again or perform it a number of additional times. In this case, we'll just go ahead and click Finish. All right. And with that complete, we'll zoom extents. And there is our resulting surface. So as I hover over the top of the surface, you'll see that it is in fact a Civil 3D surface at this point, created directly from that geospatial file. It has elevations. If we were to select it and look at it in the object viewer, we'll see that it is a complete surface. So with that being said, my first task was to construct that. We'll take that back to land. The way that I'm going to do that is through a undocumented command. Allow us to push it directly back to land desktop. Keep in mind that we also have the ability that we can output any of this data at any time to a land XML file format. Land Desktop 2009 would support a 1.1 version of land. If we were to export, Civil 3D gives us the ability to export actually to a number of different land XML file formats. But because we're going to push it back to a Land Desktop project directly, I can do that through an undocumented command called AECC export data to LDT. And it lets me push that back. Let's go ahead in my Land Projects folder. We'll select the project G for Geospatial that we just created, and we are going to push into that project the new surface we created, surface EG. We'll say OK. The migration is complete. We'll come back to Land Desktop. We can immediately go to the Terrain Model Explorer. We see that the EG surface now exists, and we'll come down to Create Contours for my surface. 1 and 5, major and minor, erase old contours, yes. And if we zoom extents, there is the same contour data from my surface in Land Desktop. All right, so a process that would have normally taken us numerous steps, 8-10 steps at least, to be able to process that in Civil 3D, we can generate a surface from geospatial data in literally just a couple of clicks. So now my main goal was to get this as well as some pipe information. So let's just change the color of this quickly. I know that just adjusting properties, we probably want to change the layer color, but we're just doing this just quickly right now. We'll switch these to be green so they're a little easier to see. We're going to come back to the Civil 3D side, and you know what? I don't need the surface anymore because I've already migrated it back into land. At this point, the next data that I'd like to bring in, I was given a shapefile that contains my structures and my pipes. I'd like to immediately convert that into geometry that then I could turn into a pipe run or deal with on the Land Desktop side. So let's do something similar here. I'm going to go to the Insert tab. Let's come down to Import, and I've got an option here for Import Geospatial Data. We'll select that. Connect to Data. We're going to come out and connect to a folder here off my desktop with geospatial files. We'll say for my sanitary sewer. And we'll connect. We'll then, walking through the wizard, continue on. This is going to be a sanitary sewer. So we'll give it the name. Parts list, just using the standard parts that exist in Civil 3D. As far as labeling, let's add a label on the pipes that include length, description, and slope. We'll say next. Okay. Much like the contours, I've got two shapefiles that exist within that folder. One is my junctions or my structures. The other one is my pipes. If they were in a different projection than what I was working with, once again, I could transform them as well. I'm not going to worry about that for right now, but instead accept the regular standard no datum, no projection. Data mapping will begin with pipes. I'm going to map those to a Civil 3D pipe shape that is circular. And here is where I would go through much the same way as my attributes with my surface. However, in the surface there was only one attribute I needed to worry about, and that was the elevation. When it comes to pipes and structures, I may have values such as rims, inverts, material, thickness, things like that. So, for example, I could say the start invert elevation. It shows me all the attributes that exist in that shapefile, and I could go ahead and start matching those things up one at a time. Much like the surface file that we just looked at, if I were to go through that process, I could save it and then reload it. So in this case, just for the sake of time, we'll go ahead and load that data. It warns me that I would overwrite what I already have. We'll grab my mapping, and we look now and we see that it's pushed those attributes into those columns that we have information for. So that will work out all right. Next, we'll do the same thing with the structures. As far as the structures go, I really only have one attribute that I'm worried about, and that is my rim elevation. We'll go ahead as far as my shapes. When it comes into structures, when the structures come in, Civil 3D supports a number of different shapes, whether it be elliptical, offset, different size structures. I'm just going to go ahead and use the default one because I've not assigned any attributes to determine that for us. So it's just going to use a cylindrical shape. Querying option, we can import all of it if it is a large network of, say, an entire county, and I'm only interested in a particular area or the subdivision or the project area that I'm concerned with. I could perform a query to do that. We won't worry about that in this particular situation. We'll say next, and then because geospatial isn't always the cleanest, I have some tools that I can clean up where I've got pipes that come together. Maybe if the values in the shapefile aren't consistent to where all my pipes meet at the same point, I don't want my Civil 3D to get confused and start building multiple structures. So I could say snap the pipes and the structure tolerance. What if they're within a depends on the data. Let's say if they're within half a foot, that's close enough. I'm going to assume they're to the same structure. If I've got any pipes that are unlinked, just basically floating out in the middle of nowhere, I could eliminate those, as well as structures. So you've got flexibility on how to resolve some of that data if you need to clean it up. We'll go ahead and click Finish, and it's going to process the data from the shapefile. Now, as it creates this in Civil 3D, it's reading those attribute values, and it's building not a pipe run that we would think of in Land Desktop, because Land Desktop would only give us a run of data from a maybe a upstream to a downstream. As far as laterals, those wouldn't necessarily be considered. In Civil 3D, it will work with a true pipe network. So what we wind up with for our resulting pipes is an actual network of the entire system. So we'll go ahead, as we look at this, we see we've got structures created, we've got pipes. It's automatically been labeled consistent with the values that came out of the shapefile. If we were to select some of this data, maybe grab structure in some of these pipes, just to show you that in a Civil 3D world, unlike Land Desktop, even though these things look two-dimensional, if we put them into a 3D perspective, oops, and I must not have grabbed my structures. We've got my pipes. We see my pipes are meeting at a point. Let's go ahead and grab these one more time. Take a look at that one more time. There we go. We'll take and pull that down, and we see our structure. All right. So once again, unlike Land Desktop, Civil 3D is model-based. So it brought in this data. We can leverage it as an entire network, not as just a standard run. And even though it is displayed in a standard two-dimensional file format, as we would expect, it is actually a complete three-dimensional network. Now, we've got a ton of intelligence that's been added here, but if we're not ready to stay in this environment and instead we'd like to move back to Land Desktop and maybe start defining runs from the geometry that's been created here, what we would do is we would come up and export this data as AutoCAD. We'll export it to a 2007 file format, which can be consumed by my Land Desktop 2009. We'll put that on my desktop here and we'll call it pipe data. Once that has been exported, we will come back to Land Desktop, and let's go ahead and insert that data. We'll browse out to my desktop here. We have pipe data. Use the same coordinates we had before. I'm going to explode it on entry so they're individual objects, and we see there are my structures exactly the way that they were created in Civil 3D. Now once again, I've lost a ton of intelligence in doing this, in that in Civil 3D it's a complete network. I've got rims, inverts, pipe objects, my structures in that. But I was able to quickly create it from a geospatial file, move it into here, and then from Land Desktop I can start to generate pipe runs as I would in this using a workflow that would support or that's supported in Land Desktop. So with that being said, as far as it relates to geospatial tools, Civil 3D has much newer tools and additional functionality that was not included in Land Desktop. We can leverage those tools in a Civil 3D environment and then start to migrate those back into Land, as witnessed through our demonstration and working with surface information from a shapefile as well as pipe data from a shapefile. And that will conclude this presentation.